Hello viewers, in today's session we are going to discuss one very important problem from definite integrals, right? So here we have to evaluate this integral from 0 to half, and we have dx over x minus 1 whole square times square root of 1 minus x square, right? So here we'll see how to find out the values of these type of definite integrals. So now let us first take the general case, right? So here we'll see the type of integrals, that is dx over x minus k raised to r, and here we have a quadratic polynomial, that is ax square plus bx plus c, right? So our given integral is of this form, and here we have the limits 0 to half, and if we take the indefinite integral, then this integral is similar to this one, right? So here we have x minus 1 raised to 2, here we have x minus k raised to r, right? And inside the square root sign, here we have a quadratic polynomial 1 minus x square, and here we have a quadratic expression ax square plus bx plus c, right? So let us see how we can integrate these type of functions when the integrand is of this form, right? So here what we do, we take x minus k is equal to 1 over t whenever x is greater than k, right? So we take this linear factor, that is x minus k, and whenever x is greater than k, we take this substitution, that is x minus k is equal to 1 over t, right? And when we have x that is less than k, then we take the substitution k minus x is equal to 1 over t, right? So to solve these type of indefinite integrals, we take these two types of substitution depending upon the relationship between x and k. So when x is greater than k, we take the substitution x minus k is equal to 1 over t, and when x is less than k, we take the substitution k minus x is equal to 1 over t. So now let us take this integral I. So we can now write I as 0 to half. Here we have dx and x minus 1 square, and here inside the square root sign we have 1 minus x square. So this is of the form 1 square minus x square, which can be factorized as 1 minus x 1 plus x, right? So here we write 1 minus x 1 plus x. Now if we look at these two terms, we see that to exist or to be valid this term, we must have 1 minus x should be greater than 0, right? Because we cannot have a negative sign inside the radical sign in the set of real numbers, right? So for the validity of this integral or this integrand, 1 minus x should be greater than 0. It means 1 should be greater than x, right? So if we compare this inequality with this one, then we can see that here x is less than 1 and the value of k is equal to 1, and here we have x minus 1 square. So here we have x minus k square, so the value of r is equal to 2, right? So to solve this integral, we'll make this substitution, because x is less than k and k is 1, so x is less than 1. So we'll take the substitution, that is 1 minus x is equal to 1 over t. So here the value of x vary from 0 to half. So let us find out the value of t, that is t is equal to 1 over 1 minus x. So when x is equal to 0, then t is equal to 1 over 1 minus 0, that is equal to 1. And when x is equal to half, the value of t is 1 over 1 minus half, that is 1 over half, that is equal to 2, right? Okay, so now here we have 1 minus x is equal to 1 over t, so that x is equal to 1 minus 1 over t. So let us differentiate x with respect to t. So we have dx over dt is equal to the derivative of 1 is 0, and here the derivative of 1 over t with respect to t is minus 1 over t square. So this is minus minus plus, so we have 1 over t square, right? So now dx can be written as dt over t square, right? So now let us rewrite this integral I in terms of t. So now I can be written as the limits vary from 0 to half. So here t varies from 1 to 2. So here we have 1, here we have 2. And for dx, we can now write dt over t square. And here we have x minus 1 square. So x minus 1 may be written as x minus 1 is equal to minus 1 over t. So x minus 1 square is minus 1 over t square, that is positive 1 over t square. So here we have 1 over t square, and then we have square root of 1 minus x square, right? So x is equal to 1 minus 1 over t, that is t minus 1 over t, right? So here we take the LCM, so t minus 1 over t. So here we have 1 minus t minus 1 over t square. So now let us look at this term. So here we have square root of 1 minus t minus 1 square is t square plus 1 minus 2t, and in the denominator we have simply t square. So now we can write it as t square minus t square minus 1 plus 2t over t square, right? So t square get cancelled, and now we have square root of 2t minus 1 over t, right? Because the square root of t square is t. So now we can rewrite this term or this integral as 1 to 2, and here this t square and this t square get cancelled. So we are left with dt over square root of 2t minus 1 over t. So this is 1 to 2, and this t can be taken to the numerator. So we have t dt over square root of 2t minus 1, right? So now we have to solve this integral. Let us make another substitution to solve this integral. So now let us take 2t minus 1 is equal to say u square. So here we are introducing a new variable. So u square may be taken as 2t minus 1, which implies that u is equal to square root of 2t minus 1. So now differentiating both sides, so we have d 2t minus 1, here we have d u square, right? So this is the derivative operator. So the derivative here we have simply 2 dt, derivative of 1 is 0, and here we have 2u du, right? So the derivative of u square is 2u. So this 2 and this 2 get cancelled. So we are left with dt is equal to u du, right? Now here the limits vary from 1 to 2. So let us take t is equal to 1. So when t is equal to 1, u square is equal to 2 times 1 minus 1, that is 2 minus 1, which is 1. So u is the square root of 1, that is 1, right? And when t is 2, then the value of u square is 2 times 2 minus 1. Here we take t is equal to 2. So this is 4 minus 1, that is simply 3. So u is square root of 3, right? So when t goes from 1 to 2, u goes from 1 to square root of 3, right? So now this integral I may be written as that is 1 to square root of 3, and here we have t dt. So t is now equal to u square plus 1 over 2, right? Because 2t minus 1 is u square, so 2t is equal to u square plus 1. So t is equal to u square plus 1 over 2. So here we have u square plus 1 over 2, and for dt we can now write u du, and here for square root of 2t minus 1 we can write u. So u and u get cancelled. So now we have I is equal to 1 to root 3, and here we are left with u square plus 1 over 2 du. Taking half outside, and we have 1 to root 3 u square plus 1 du, and now we can find out the integral of u square is simply u cube over 3, and here the integral du is simply u, and limits are from 1 to square root of 3. So let us substitute the limits. So we'll take square root of 3 here. So we have square root of 3 cube over 3 plus square root of 3, and then we have 1. So this is 1 cube over 3 plus 1, right? So we can simply solve these two expressions. So this is 3 root 3 over 3 plus square root of 3, and then here we have 1 over 3 plus 1, that is equal to 4 over 3. So here 3 and 3 get cancelled, so we have half, and square root of 3 plus square root of 3 is 2 times square root of 3. Here we have 4 over 3, right? So now multiplying these two terms by half, this 2 and this 2 get cancelled, so we have square root of 3, and here 2 2s are 4, and we have here simply 2 over 3, right? So viewers, the value of this integral is given by square root of 3 minus 2 over 3. So we can also write this expression as 3 root 3 minus 2 over 3, right? So this is how we can solve these type of definite integrals. Hello viewers, in today's session we are going to discuss another important problem from definite integrals. So here we have to find out the value of this important definite integral from 0 to infinity, and the integrand is x divided by 1 plus x times 1 plus x square, right? So here what we will do, we'll first take this integral as I, right? So whereas if we closely inspect this integrand, we can see that we can resolve this integrand into partial fractions, right? So this integral can be solved by two methods, one by method of partial fractions, and the other method is by method of substitution, right? So we can first resolve this expression, that is x over 1 plus x times 1 plus x square, into partial fractions, right? So we can write here a over here we have a linear factor, so we can write a over x plus 1, and then here we have a quadratic function, right? And this quadratic function is it cannot be resolved into linear factors. So when we have a quadratic function which cannot be resolved into linear factors, then we write a term like this bx plus c in the numerator, and here we have x square plus 1, right? So we can resolve this integrand into partial fractions, and then we can find out the values of a, b, c, and then by a method of usual integration we can find out the integral, and then by applying the limits we can finally find out the value of this integral, right? But here we are not going to use the method of partial fractions, right? So here we are going to use the method of substitution. So let us start. So here we'll take the substitution, that is x is equal to tan theta, right? So this is the most appropriate substitution here. X is equal to tan theta, so that if we differentiate x with respect to theta, we'll get dx over d theta as the derivative of tan theta, and this is secant square theta, right? And from trigonometry we know that secant square theta is equal to 1 plus tan square theta. So now we have 1 plus tan square theta. Tan theta may be replaced by x, so we have 1 plus x square, right? So dx over d theta is equal to 1 plus x square. So it implies that d theta can be written as dx over 1 plus x square, right? Okay, so now here the limits of integration vary from 0 to infinity. So when x is equal to 0, then the value of tan theta is equal to 0 from this expression. So this implies that theta is equal to 0. Now when x is not defined or infinity, then tan theta is equal to infinity. So theta is equal to pi over 2, right? So we can say that when x varies from 0 to infinity, then the value of theta vary from 0 to infinity. So now what we will do, we'll write this integral I in terms of theta. So we have now I, then the limits are from 0 to pi by 2, and for dx 1 plus x square, dx over 1 plus x square, we can write simply d theta, and then for this x we can write here tan theta, and for 1 plus x we have 1 plus tan theta, right? So now the integrand is x, that is tan theta. Dx over 1 plus x square may be replaced by d theta, and then 1 plus x, that is x is tan theta. So now we will simplify this expression further by writing tan theta is equal to sine theta over cosine theta. So now we have here 0 to pi by 2, then we have sine theta over cos theta, here we have d theta, and here we have 1 plus sine theta over cos theta, right? So let us simplify it further. 0 to pi by 4, we have sine theta over cos theta, here we have d theta, and now multiplying this 1 by cosine theta, we have cos theta plus sine theta divided by cos theta. Now this cos theta and this cos theta get cancelled. So now we have I is equal to 0 to pi by 2, and we are left with sine theta over cos theta plus sine theta, right? So now we have to evaluate this integral. And now if we look at the problems of definite integrals using the properties of definite integrals, this is a very simple problem, right? So here we'll make use of an important property of definite integral, which says that the integral 0 to a f of x dx is given by 0 to a f of a minus x dx, right? So 0 to a, so here a is pi by 2, and f of x, that is f of theta, is sine theta over cosine theta plus sine theta. So now we can write here 0 to pi by 2, this is I sine theta. Now theta may be replaced by uh, that is pi by 2 minus theta, due to this property, because here we have f of x and here we have f of a minus x. So a is pi by 2 and x is theta. So here the variable is theta. So we have pi by 2 minus theta. Here we have d theta divided by cos pi by 2 minus theta. Then we have sine pi by 2 minus theta, right? So let us simplify it. So we have 0 to pi by 2 sine 90 minus theta. So we have to go back to the formula list of trigonometry. So sine 90 minus theta is cosine theta, and then cos 90 minus theta is the sine theta, and here we have plus cosine theta, right? So now we started with this integral, so let us take it as integral number 1, and by applying the property we got this integral, right? This is integral number 2. So now if we add these two integrals, then we have I plus I, then we have 0 to pi by 2. The first integral is sine over cos, this is sine, and here we have theta. Then this integral is 0 to pi by 2. Then we have cos theta, and here we have sine theta plus cos theta and d theta, right? So I plus I is 2i, and here we have 0 to pi by 2, and see, here we have sine theta plus cos theta, here also we have sine theta plus cos theta, and the integral, the limits of integration are same. So we have 0 to pi by 2, so we can add these two quantities. So the denominators are same, so we can simply add the numerators. So we have sine theta plus cos theta, and in the denominator we have simply sine theta plus cos theta, right? Sine theta plus cos theta, this is also sine theta plus cos theta. So here we have d theta. Now these two terms get cancelled, so we have 0 to pi by 2, and here we have d theta, right? So now we have 2i is equal to 0 to pi by 2 d theta. This is 2i, the integral d theta is theta, limits are from 0 to pi by 2, so this is 2i, pi by 2 minus 0, substituting the limits and taking the difference, this is pi by 2, right? So I is pi over 2 times 2, taking this 2 to the denominator, we have pi by 4, right? So the value of this integral is equal to pi over 4. Hello viewers, in today's session we are going to discuss a very important problem from definite integrals involving the absolute value function of cosine x, right? So here we have to solve this integral in which we have the integrand as mod of cosine of 2x, right? And the limits of integration vary from 0 to pi by 3. So let us see how we can solve this integral by making use of some concept from trigonometry, and then by definition of absolute value function. So let us start. Let us take this integral as I. So here the limit of integration vary from 0 to pi by 3. So x belongs to the interval 0 to pi by 3. Now here the integrand may be taken as f of x is equal to mod of cos 2x. Now see, to find out the value of this integral, we have to make use of the sign convention of trigonometric functions in the four quadrants, and then we'll make use of the definition of absolute value function. So let us first apply the method of substitution. So here we have cos of 2x. So let us substitute theta is equal to 2x, so that d theta over dx is equal to 2 times 1, because the derivative of x with respect to x is 1. So here we have 2. So d theta over 2 is equal to dx. Now, the limits of integration are from 0 to pi by 3. So when x is 0, then the value of theta may be obtained by using this relation. So we have 2 times 0 is equal to 0. And here, when x is pi by 3, we have theta is equal to 2 pi by 3. So theta goes from 0 to 2 pi by 3. So now we can rewrite this integral I in terms of theta as theta from 0 to 2 pi by 3, and here we have mod of cosine of theta, and dx is d theta over 2. So this is half. Taking half outside the integral, we have 0 to 2 pi by 3, the mod of cos theta and d theta. So now let us take the sign convention of trigonometric functions. So here we have the first quadrant, this is second, this is third, and this is fourth. Here we have 0, here we have pi by 2, here we have pi, this is 3 pi by 2, and this is 2 pi, right? So here we have four quadrants, and we know that in the first quadrant, all the trigonometric functions are positive, right? And in the second quadrant, we have only the sine function is positive, and the remaining trigonometric functions are negative. So here, since the limit of integration vary from 0 to 2 pi by 3, and 2 pi by 3 is 120 degrees, right? So we have to go from 0 degree to 120 degree, and 120 degrees, it lies in the second quadrant, right? So this is 120 degrees. So we are in the second quadrant. So now in the second quadrant, the cosine function is negative, and in the first quadrant, cosine function is positive, right? So we can now use the definition of the absolute value function, which says that mod of p is equal to positive p whenever p is greater than or equal to 0, and mod of p is negative p whenever p is less than 0. So now we can break this limit, that is 0 to 2 pi by 3 at the point that is pi by 2, right? So here we have 0, here we have 2 pi by 3. So we can break it at this point, which is pi by 2, right? So we'll write this integral as a sum of two integrals. That is, one is from 0 to pi by 2. Then we have mod of cos theta, d theta. Then here we have from pi by 2 to 2 pi by 3. Here we have mod of cos theta and d theta, right? So when we go from 0 to pi by 2, it means we are in the first quadrant, right? And when we go from pi by 2 to 2 pi by 3, we are in the second quadrant, right? So when we are in the first quadrant, it means the cos function is positive. So we can write mod of cos theta is equal to positive cos theta when theta belongs to the interval 0 to pi by 2. right? So here we can now write half, and here we have 0 to pi by 2, and mod of cos theta is positive cos theta. And now in the second integral, we are in the second quadrant, and in the second quadrant the cosine function is negative, right? So we have mod of cos theta is equal to negative of cos theta when theta belongs to the interval pi by 2 to 2 pi by 3. So this is the important concept here. So we have pi by 2 to 2 pi by 3, and here we have negative of cosine theta. So in other words, we can also say that when theta belongs to the interval 0 to pi by 2, cosine theta is positive, right? And when theta belongs to the interval pi by 2 to 2 pi by 3, then cosine theta is negative. So now we have to solve these two integrals, and we know that the integral of cosine theta is given by sine theta. So here we have I is equal to half, and then the integral cos theta is simply sine theta. Limits are from 0 to pi by 2, and here we'll take this negative sign outside, and then integral of cos theta is sine theta. Limits are from pi by 2 to 2 pi by 3. Now we have to simply substitute the limits, and we'll take the difference. In the first case we have sine pi by 2 minus sine of 0, and here we have sine 2 pi by 3 minus sine pi by 2. And now we can write the values of sine pi by 2 as 1, sine 0 is 0, then sine 2 pi by 3 is the square root of 3 over 2. These are the simple values. Sine pi by 2 is 1. So here we can simplify this expression. So we have half, 1 minus 0 is 1. Then we have minus square root of 3 over 2, minus and minus plus. And this is half. 1 plus 1 is 2, 2 minus square root of 3 over 2. And if we multiply these two terms by half, we have 1, 2 and 2 get cancelled. And then 2 times 2 is 4. So we have root 3 over 4, right? So viewers, the value of this integral is given by 1 minus square root of 3 over 4. So here I would like to mention one important thing, that see sine 2 pi by 3. So we can also find the value of sine 2 pi by 3 by making this change, that is 2 pi by 3 may be written as pi minus pi by 3. So we have 3 pi minus pi, that is 2 pi by 3, and sine pi minus theta is given by sine theta, and here theta is pi over 3. So we have simply sine pi by 3, and sine pi by 3 is sine 60 degrees. Sine 60 degrees is square root of 3 over 2, right?